This is the test review for Unit 1. A squirrel can run 1 mile in 5 minutes. What is its running rate in miles per hour? So there's a couple of different ways that you can do this. If a squirrel runs 1 mile in 5 minutes, then the squirrel can run 2 miles in 10 minutes. So for every 5 minutes, the squirrel runs another mile. And so on. So 15, 20 minutes now, 25, 30, 35, 40, 45, 50, 55, 60. So there's our hour. And from here we got 4 miles, 5 miles, 6 miles. So for each of those 5 minutes, another mile. 7, 8, 9, 10, 11, 12. So we know the squirrel can run 12 miles for 1 hour, or 12 miles per hour. Another way to do it is you could set it up as a fraction, 1 mile for every 5 minutes. And you can do unit conversion, is where you multiply by another fraction that is equal to 1. And the way you do that is you want, in this case we want hours, but right now we have minutes. So how is hours and minutes related? Well, 60 minutes is equal to 1 hour. And those two things are exactly equal. So if you put there's a reason I'm putting the 60 minutes on top. The reason why is because we want to eliminate the minutes and we want hours to be left over. So because I already have minutes on the bottom, the other minutes are going to need to go on top so that the minutes cancel out. So I would put 60 minutes and then the 1 hour on the bottom. So notice that 60 minutes and 1 hour, those two things, these are equal, exactly equal in value. Therefore, putting one on top of the other really gives you the number 1. Just like 4 over 4 is 1, x over x is 1. They're equal in value even though they look a little different. So we're really just multiplying 1 mile over 5 minutes by the number 1. And our minutes are going to cancel out. Just like 4 over 4 is 1, x over x is 1, minutes over minutes cancels, it's 1. And we multiply straight across with fractions, so 1 times 60 is 60, and I'm left with miles. Bottom, 5 times 1 is 5, and I'm left with hours. And then if I go one more step, 60 divided by 5 gives me 12 miles per hour. So either way you want to do this problem is just fine. They both get you 12 miles per hour either way. The next one, you have $200 in your bank account and another $78 hidden under your mattress. You're going to pay your mom $30 a month for your cell phone. How long can you afford to pay her if you do not get a job? So you got your $200 and your $78. So really you have $278. And you are going to need to pay your mom $30 every month. So really, we want to know how many 30s we're going to be able to pay her with that $278. And because that's our total amount of money, and I need to pay my mom $30 per month, we can set those equal. And the way we solve for m, or the number of months we can afford, is dividing. So we got 30 over 30 is 1. 278 divided by 30 gives us a decimal of about 9.27. And that's rounded. But I can't pay my mom for part of the month. I either pay her for 9 months or I pay her for 10. I can't afford to pay her for 10 months. So in this case, I can only pay my mom for 9 months. That's how long before I'm going to have to get a job of some kind. Number 3, the formula for the area of a rectangle is area is length times width. Express L in terms of A and W. So we're expressing L. L is what we're solving for, whereas A and W is going to be on the other side. A and W. So then from here, if I want to express L or solve for L, the L and the W are multiplying. So to get rid of that W, you got to divide out on both sides. W over W is 1. And you're left with A over W is equal to L. And that's our answer. And you could write it as L is A over W, but they are the same thing. The next one, the formula for the area of a trapezoid is area is 1/2 times the height times inclusive base 1 plus base 2. And we want to solve for base 1. So everything has to get away from the base 1. And because the 1/2 and the h are already on the side, we don't want to throw them in by distributing because we're trying to get rid of them. So instead of distributing and throwing them into B1 and getting it more crazy, we want to get rid of those. And the 1/2, to get rid of fractions, we're going to flip the fraction and multiply it to both sides. Because, now look, 2 over 2 right here, you got a 1. 1 over 1, you got a 1. So they're gone. Which is nice because then now you don't have any more 1/2. You got just what's left. And on this side, we got 2 over 1. Well, really, 2 over 1 is just 2. 2 divided by 1 is still 2. And anything over 1 is just the number you had to start. So it's just 2a, 2 multiplied a. And now we want to get rid of that h because we don't want to distribute it in. We want to get rid of it. So that h is multiplying to everything. So if we divide it out to everything on both sides, h over h cancels. And now we got 2a over h equals b1 plus b2. I want to get b1 alone. So the last step, get rid of that b2 by subtracting base. So you got b2 minus b2 is 0. They're gone completely. And you got b1 is equal to 2a over h. Subtract that b2. That is our final answer. Next problem. We got write the equation 4x minus 5y equals 25. We want it in slope-intercept form. That means we want y alone. The way that we got to do that, the 5 is multiplying, and the 4x is out here on this side. So 4x is actually the first thing to get rid of, because to get rid of the 4x, that's how we're going to get our 0. So if we have 4x positives, we got to subtract them from both sides. We want them completely gone, completely 0. And 4x take away 4x is 0. So we got negative 5y. And then there's two ways that I can write this. I can write this as 25 minus 4x, or I can write it as negative 4x plus 25. Now the reason why is because the 4 still has that minus in front, no matter which way you write it, and the 25 is still positive, no matter which way you write it. So they are the same. And I'm actually going to go with the form that has x first, because that's how y equals mx plus b is written. It's got x's first. So I'm going to put negative 4x first plus 25. And then I need to get rid of the negative 5. So to get rid of negative 5, we got to divide it out since negative 5 and the y are multiplying here. A number and a letter multiply. And I'm going to divide negative 5 out to each term. Negative 5 over negative 5 is 1. I got y equals. Negative and a negative makes positive, so I got 4/5. I could keep it as 4/5. If I divide those out, I get 0.8. And I'm going to keep it as 4/5, and the reason why is because I know that in this particular problem, that m represents slope. And slope is great as a fraction because it gives us the rise and the run. So I'm going to leave it as 4/5 x. And a positive 25 divided by a negative 5 is negative 5. So our final answer, y equals y equals positive 4/5 x, subtract 5. Okay, number 6, flower pots F is $12 each. Trees cost, that's supposed to be cost, not, has a T at the end, 40 each. If Matt has up to $500 to spend on flowers and trees for his yard, we're going to write the inequality. So his flower pots F are $12 each. Every time he buys a flower pot, he's got to pay that $12. So you got $12, $12, $12. We don't know how many $12 he's spending, so we got to have 12 and a variable next to it. Because what's repeated addition? 12 plus 12 plus 12 plus 12. We don't know how many 12s. Is multiplication, so we got to have multiplying there. 12 times F. Plus, you got to add on the cost of the trees. So 40 each. 40 times how many trees he's buying. So who knows? 40 plus 40 plus 40. And keep going. So we got to multiply it. Repeated addition, multiply it by T, because we don't know how many. He's got up to $500. That means he cannot spend more than his budget. So he's got to be less than, and he could equal it, because it says up to. He could spend that much or less. He can't go over his budget. So less than or equal to $500. That's it. You got your total amount of money he's spending on flowers and trees is less than his budget, $500. Next one, number 7, we're going to distribute that 2.5. So we got 30 plus 16b less than or greater than or equal to 16b, and that's 31.5. And now from here we want to get variables on both sides. Those b's got to get together. So here we got 16b. We want all of them gone. We want 0, so we're going to minus 16b both sides. And actually on this one, the b's cancel out from both sides. They're completely gone. And we're left with 30 is greater than or equal to. Bring down 31.5. 30 is greater than or equal to 31.5. Or look at it. Is the alligator eating the bigger number? No, he's not. Therefore, this problem has no solutions. There is no number that you can plug in that will make that statement true. It will not happen. Next one, what if the coefficient of x, coefficient is the number in front of x, and because it says coefficient of x, we're going to find out what that number in front of x, or that b value, needs to be if the solution is x is greater than 12. So we got x and we got 12. We're going to plug that 12 in for x. B, plug in that 12 and 24. We want b alone. We want that coefficient solved for, so we're going to divide out that 12. 12 divided 12 is 1. B is less than, and that's negative 2. So b is less than negative 2. So now look at it if I write that back in there. Negative 2x less than negative 24. So you're kind of